Hello class again and welcome to this particular video, and please don't forget to bring out your notes and please write the bell work for today, and take note that this is going to be focusing on part 3, which is the finale of our angles videos, which involves, in this time we're going to be able to relate when lines they connect to the angles that are created. So before, on our previous videos, we looked at just 2 lines and we discovered how to measure angles in this particular example right here for case 1. But in this particular video, take note that we are going to be first, got to write the bell work, which is look at the lesson in focus, which is transversal and corresponding angles. And our goal is to be able to define and identify transversal with lines and that of corresponding angles. So all these are kind of key terms to keep in mind, and also you need to be able to be able to identify angle relationships and when lines they relate in a way. So looking at case 1 in here, we're going to look at when 2 lines they intersect. We know that for intersecting we need 2 or more lines to meet at a point, and in this particular case we have this particular point, which is where these 2 lines they meet, and this region is called the intersect. And so the intersect is the region where 2 or more lines they meet, and in this case the green line and the orange line they meet at that particular point. So our goal here is to determine the angles that are created when these 2 lines they meet. So we have this space here, we have this space right here, we have this other space right here, and finally we have this particular space right here, and we need to determine the angles. Remember, for review, to determine the angles, all you need to do is grab a protractor, line it up, and to line it up you need the vertical line to match really well with, in this case, the green line, and you need the specific circle to match the point where they meet. And what we notice is that this particular space, which is from this green line all the way to the orange line, they meet at a region which is around 114. So since we have this space to be 114, it means that for this other side here, which is the angle will be 66, going from 0 all the way to this particular mark right here, which shows that it is 66, while from here, from 0, we count using this lower calibration numbers, and we see that it is 114. So in this case, we have our angle that is made on this side to be from here to here to be 114 degrees, and while from here to there, I'm going to change it to a different color because I want to show you something that is kind of cool that we are going to observe in here. From here to here is around 66 degrees. So now you have this particular space right here. How about this other space right here? How are you going to measure that? And a good way to go about it is by, let's flip our specific protractor in this other direction, and by rotating your protractor and lining it up as well as we did on our previous step, we see that the angle made from 0 all the way to here is also the same number as what we have right here, which is 114. And if you count from this green line to this orange line on the other side, we see that counting from 0, it actually touches at around 66 degrees. So indeed, we've come up with a conclusion based on the pattern, and the pattern indicates that the angle that corresponds here is shown to be identical to the angles that are corresponding around that same point on the other side. So therefore, we have this angle here to be measured to be 66 degrees, which is the space that is directly facing opposite to the other angle, and they are the same. And while this 114 degrees has an angle that is directly facing the other side, which is also measured here to be, change the color just to keep it smooth and nice, to be in this case 114 degrees. So this shows you the corresponding angles that are noticed when two lines they meet at a particular point. So please keep this in mind and how we are going to use this particular strategy to answer other questions. So take note here that this same pattern of angles is exactly the same thing as this case 2 between the orange and the green line. And so while I'm going to rewrite this, you're going to see some interesting things that are noticed in terms of this case 2 here. So in here we have 114 degrees as our measurement, and we measured this as well to be 114. And in this case here we have this other side for the green side to be from here to here to be 66 degrees, and we have this as well to be measured to be 66 degrees. So now what makes this at the top here different from the one right here? Why the one at the top just has two lines and they intersect at a point? Now we have one line that intersects not one but two or possibly more lines, but in this case we're going to be dealing with two lines that are intersected by one line. And what we see is an example that looks like this. We're going to label our orange line to be line. I'm going to write it here. Orange line. Line is labeled as the line OP. That is something to keep in mind. So line OP is the orange line, and the other line here, green line, is labeled to be, in this case, using the alphabet N. Yes, and we have a little bar at the top, and then we have another line here which is the blue line, and the blue line is labeled to be what? AB. So that is how we label lines, and we use those labels to identify lines in mathematics. So blue line is labeled to be, in this case, AB, and based on these labeled lines we want to talk about what line is defined as transverse line. So in this case here, the transverse line is the line that intersects one or more lines. So in this case, MN and AB, they don't intersect directly as you see in this particular diagram, but one line touches one or more lines, and the line that touches one or more lines is, in this case, the most number of touches is considered to be OP. So therefore OP is considered to be indeed the transversal line, and the transversal line is a line that intersects more than one lines or the most number of lines in a diagram. And so OP is considered to be that, and OP touches not only the green line but also touches the AB line, which is the blue line. Take note also that why is this MO not parallel to AB? Now on our previous video we talked about parallel lines, and we said that parallel lines are lines that never touch, but in this case we are saying that they don't touch directly. Why is that the case? The reason why is because we haven't extended the lines to a further point. So take note that at some point in the future when you extend the lines, you will notice that these two lines, they will meet somewhere around here. And so this is a great way to confirm that, hey, these two lines, they are not parallel, and they will always meet at a specific point, which is somewhere around here. But you might be asking yourself, what if you're not given this particular clue right here right away? And in this case you're asking yourself, how are we going to know that these two lines are actually not parallel? So another way to check that these two lines are not parallel is by comparing the angles based on where the one line intersects the two lines. So we have the OP line, they intersect at two lines. So now we need to explore the angle to see carefully whether the angles setup arrangement that are here is going to be the same as what we have over here. If they are the same, then it means that line MN is not, if the angles here are the same, it means that MN line, it is parallel to AB. But if the line angle set up here is different from the angle set up here, it means that MN line is not parallel to AB. And to confirm that, we drag our protractor and we check out what the angle measurement is right here. And so by so doing, we'll be able to identify what is our result based on our arrangement. And so to do this, take note that it's kind of difficult to rotate this protractor to match these lines properly. So what I'm going to do is I'm going to do some little subtraction and additions to see what is our outcome. So when I drag this properly to the point where these two angles they meet, and I actually figure out what, yes, so they meet around this particular circle point region here, and then I do my little mathematics and I notice that measuring this particular line here where it touches to this particular point right here, this shows that, hey, from the blue line, which is around 10 degrees here, to this other point here, which is around, if you look closely, it is close to, counting using the sticks here, we see that 10 degrees, and this is around 115 degrees. So 115 degrees minus 110 degrees is something that we need to keep in mind in terms of the specific angle that we are looking at. So 115 degrees minus 10 degrees is going to be, in this case, around 105 degrees. And so the angle here from the blue line to the specific orange line is measured to be 105 degrees. And so by default, this particular space right here from the orange line to the blue line here is going to be, take note, because a full angle on a straight line is 180, so we can just go straight away by saying 180 degrees. Take note, this is not Celsius, not temperature, minus, in this case here, we're dealing with 105 degrees. This will give you, in this case here, 85, no, not 85, let's see, 75 degrees, sorry. So it will give you 75 degrees. And so therefore we are able to recognize that, hey, this particular angle measurement right here is not the same as the one that we discovered or determined in this particular point where the orange and the green line meets. And if you do the same thing as how we were able to determine the upper angles, we can actually determine that, hey, there is a corresponding angle relationship between the specific lines right here. And the specific relationship in angles is as follows. In here we have corresponding angles here that is inverse at the top right here. So therefore this particular space that is directly facing the space at the top is located above here. And so this measurement is also, in this case, 105 degrees. And while this angle here space that is directly facing the other side is also measured to be 75 degrees. And so therefore we are able to confirm that, hey, the angles here combination we see here is not equal to the angle combination in here. As a result of that, we are going to make our conclusion that, hey, this line MN, which I'm going to write right here, MN line is not, I'll use a red line to create a stroke, it is not parallel to the line AB. So this is something to keep in mind in this particular case right here. And so this is where we are done with our case number 2. And case number 3 is when you have 2 or more parallel lines that are intersected by a transverse line. So take note that the orange line here is considered to be the transversal line because it touches more than 2 lines in this particular space. And take note that the 2 lines or more that it touches, they are parallel. And how can we check to confirm that? How we check to confirm that is by, from our previous video steps, we notice that this angle space here between the green line and the orange line is 114 degrees, and this here is 66 degrees, and this one as well is corresponding to the other one right here. And so what we see is that this line here, to check that it is parallel to this particular line right here, which is the green line, we are going to use our protractor and see whether they do give the same angle. And so when you drag this all the way to this measuring location right here, and we find our result, we see that, hey, the angle that we have here is the same as this particular region right here in terms of the angle, and also is the same as this particular region right over here when you extend it over properly. And so in conclusion, this tells us that, hey, these lines here, the green lines, they are parallel to each other because they have the same angle distribution, which means they are all corresponding angles to each other. They all correspond to each other based on the angles. So that is how you're able to confirm that lines that are parallel but are having a transverse line that cuts through those lines, they do have the same distribution of angles. And so therefore, if you're asked that what is the angle here, the angle here is, without using your protractor, is 114, because this line here and these lines here, they are parallel to each other, which means they never meet. And in this case here, if they never meet and they have a transverse line that cuts through them, it means that all these angles here in this case will be 114 degrees. Where else is 114? If this is 114 degrees, this at the bottom here will be 114 degrees, and this one here is 114 degrees. And what other angles are missing? Oh, we have this one right here. If this is 66 degrees, this top here will be also 66 degrees, and this angle here is also 66 degrees. And how about this one here? We know that this is 66 degrees, which means this one at the bottom will be also 66 degrees, and this one right here will be 66 degrees. So that is how we are able to assign angles when you have transverse line that cuts through parallel lines, which will give us the same angle distribution, which are corresponding angles, or when you have a transverse line that is intersecting non-parallel lines, we're going to have a different angle distribution at one intersecting point compared to a different intersecting point. So please make sure that you go through the questions that are on your Hapara workspace, practice questions, and also the inquiry one. And if you have any questions, please don't hesitate to contact me by G or Google Meet ask any questions if you have any questions. But that way we can discuss it on our Google Meet. All the same, please don't forget to stay smart as always and believe in yourselves.